In this tutorial, we will be looking at linked lists in C++. In the video description, you can access the source code for this tutorial. Simply copy and paste the code into your own C++ project. Basically, a linked list is a data structure that can store an indefinite amount of items. These items don't have to be the same data type. As long as pointers connect these items in a sequential manner, it technically counts as a linked list. There are several differences between an array and a linked list. While both are data structures that can store multiple values, an array is both physically and logically contiguous. That means that each element in an array is located next to each other in physical memory. A linked list, by contrast, is only logically contiguous. The nodes of a linked list are not necessarily next-door neighbors in memory. Because of this flexibility, node elements can be different sizes and different data types. Perhaps the most obvious difference between a linked list and an array is the fact that an array is a fixed length, while a linked list can expand or shrink during runtime. One advantage an array has over a linked list is indexing. Instead of having to traverse down every element in the array, you can access an element directly by its index number. This costs only one instruction cycle. To get the fifth element of an array, you only need to perform one lookup operation. The same operation in a linked list would cost you 5 instruction cycles, since you have to inchworm your way down the list. One advantage a linked list has over an array is the ease of inserting and removing elements. In order to insert an element into the middle of an array, you have to shift each element over to make space for the insertion. This can be quite costly. In a linked list, however, all you need to do is reassign the pointer of one node to make it point to the new element, and have that new element point to the next logical node in the sequence. There are several kinds of linked lists. In a singly linked list, each node has only one pointer, commonly called next, since it points to the next node in the sequence. The last node in the list points to null. A doubly linked list has two variables, one pointing forward to the next node and one pointing back to the previous node. In this tutorial, we will create a program for a singly linked list, since it's the simplest kind of list. We will use the list to represent a music playlist, where each node represents a song and artist combination. In designing a linked list class, it's helpful to use a UML diagram. We will specify the data members and methods for the class. Let's create two data members, one for storing a reference to the linked list, and another for storing the length of the list. Let's define 5 methods for the linked list class. The constructor will create the head of the list and set the list length to 0. Note that the head node is not the same thing as a data node. To add data nodes, the stuff we actually care about in the song playlist, we will use an insertion method for adding a data node anywhere in the list. If the operation is successful, it will return true. If, for instance, the position number is out of bounds, the insert method will return false. We will also have a corresponding remove method. This will delete nodes from the list. At some point, it will be useful to see the contents of the list, so we will make a print method. And finally, we need a destructor method to deallocate any memory used to create this linked list. Since each node is a dynamic variable, it will be taking up space in RAM, so it's important to release this memory once it's done. In other programming languages, like Java, we wouldn't worry about a destructor method since it has automatic garbage collection, unlike C++. For the complete coding example, please visit the link in the video description. On the page, you will find everything you need to make a working program. There you can copy and paste into your own C++ project all the files you need. Thanks for watching.